Number 48, letter A. A 200 turn circular loop of radius 50 centimeters is vertical with its axis on an east-west line. A current of 100 amps circulates clockwise in the loop when viewed from the east. The Earth's field here is due north, parallel to the ground, with a strength of 3 times 10 to the minus 5 Tesla. What are the direction and magnitude of the torque on the loop? All right, so I think this is what it's saying. Basically, here's the ground. You got your little loop right here. And it tells us that the axis of this circular loop is on an east-west line. So in other words, here's the east-west line, okay? And as we talked about in number 42, the normal is what's important here in once we start calculating, okay? And the normal is this kind of 90-degree angle relative to the surface. All right, check out number 42. So here what I'll write is I'm going to draw in the normal. And what they start telling me now is they start mentioning, and maybe what I'll do is I'll angle this ever so slightly to kind of show it, give it a little depth. But I don't know, that looks stupid. Okay, so that's the normal. It's creating a nice 90-degree angle there. And now it is mentioning that the Earth's magnetic field is due north at this point. So due north is actually going to be into the page. Okay, pretend you're standing here and you got your compass in your hand. Due north would tell you to go, you're looking at the computer screen, due north would tell you to go forward, or meaning into the computer screen. Okay, so into now is going to be all these X's. All right, now these X's, right, it's really like a line that's pointing into the computer screen. And that's going to create a 90-degree angle there with the normal. Okay, keep that in mind. All right, that's the north field. So now we should have enough firepower in order to calculate the direction and the magnitude, and the magnitude of the torque, okay, on the loop. So let's first calculate the magnitude of the torque. So the torque here is going to be, as we've seen before, check out number 42, is the number of loops multiplied by the current flowing through the loop, multiplied by the area of the loop, multiplied by the magnetic field strength that the loop is experiencing, multiplied by then the sine of the angle between the magnetic field and the normal, all right, of the loop. And here they're calling the normal the axis. So, you know, you can just be careful. There's a couple different terms that they can use. So the number of loops here they told you was 200. The current here is going to be 100 amps. The area, it's circular. What's the area of a circle? It's pi r squared. They gave you the radius, right? 50 centimeters, but you know we need that in meters, so convert that into meters and then square it. Magnetic field strength, they told you, 3 times 10 to the minus 5 Tesla. And what's the angle? Did they say circulates clock? Oh, right. Okay, so that's another piece I'll have to take into account. But 1 second. Parallel to the ground. So basically, it doesn't explicitly detail, but if the axis of this loop, as we had mentioned, you know, is in the east-west direction, and this, you know, magnetic field is pointing north, they are at 90 degrees to one another, and therefore sine the angle there would be 90. So simply just now plug this on in, okay? So we're going to have now 200 times 100 times pi times 0.5 squared times 3 times 10 to the minus 5th. And then, you know, sine of 90 is just 1. So this works out to be 0.471 Newton meters. Okay, that's the torque that the wire is experiencing. And the other thing they told us, but, you know, it just says it circulates clockwise in the loop, the current that is. So if you were looking at the loop here, right, in black, and you were looking at it from the east, so you're literally on this side looking at it that way, right, because this is east, and then that would have been west out there, right? The current is flowing clockwise, right? So it's going in this direction. Whoop. Okay, it's going whoop. Just like that. Clockwise. I don't know why that did that again. It's going clockwise. All right, in any case, that takes care of that, okay? And so now it's asking about what is the direction. So what we have to do here is it wants to know the direction. What is the direction of the torque, right? Okay. So in order to take into account the direction, right, or find the direction of the torque, we do have to talk about the direction of the current, which we just, and that's why we just did, right? So consider that it's going clockwise. Now pick a point. Pick this point. If it's traveling clockwise, that means it's going down, right? Right at that point, basically. Now remember, use right-hand rule number 1 here. If your thumb is going down, that represents the current, and then your fingers must be pointing here into the computer screen. Okay, so thumb is pointing down, fingers are pointing now into the computer screen, right? Which way then will the force be on that particular point of the wire? It will be pointing to the east, right? So let's write that down. So the force here is pointing to the east, okay? East force. Now, as the loop makes its turn around, okay, let's pick this point now. So now remember, the current is going up. So point your thumb up towards the ceiling. Your forefingers should be pointing then into the computer screen. And if you notice now, the force then is going to be pointing to the left, right? Because that's where your palm's pointing. So now what you have to do is you have to look at this, right? If you have, pretend, right, here's the middle now of the loop. If you have a force pointing this direction on the back side of the loop, and then you have a force pointing in this direction, right, which way then is the loop going to rotate? Well, it looks to me like the loop is going to rotate like this. Oops, like this, right? It's going to rotate like that. It's going to rotate around like that. Okay, so in other words, when you view this, if you were to view this from the top or the bottom, it doesn't really matter how you view it. But if you were, almost imagine now you're up here. Oh, look, here I am. I'm floating in the air. And you're looking down at this thing. What direction would this be then as I'm going around and around? That would be clockwise, right? Wouldn't it? So that's how you can give the direction. If you were saying, oh, I was underneath it here, buried underground, right? What direction would that be? If you were still looking at it, right? What do you think? You got to be careful. It's going counterclockwise now, okay? Because you're kind of flipping the left and the right-hand side. So it just depends on your perspective. So anyway, the direction is going to be clockwise viewed from the top. You can view it a whole bunch of ways, all right? That's the torque. Does this device have any practical implications as a motor? Whatever. Guys, thanks for tuning in. Hopefully that helps. Please remember to help us out and subscribe if you can, and we'll see you soon, all right? Take care.